In this video, we will derive the cosine of a difference identity. It's the first of the four cosine or sine sum or difference identities. So let's start with this image over on the left. Over on the left, we have the first circle, which has the distance AB. Distance AB, which we are going to say this distance is going to be the same distance as this CD. So we're going to say that AB equals CD, or is congruent, at least, so the distance. And we're saying that AB is constructed by these two rays. The first one is going to be made by the so B is going to be made by the angle V, and then A is using the angle U. So to get this theta here in the second one, theta is going to be equal to U minus V. Okay, so now that we know that, let's go ahead and let's find the distance. So let's use the distance formula. So we know the distance is x2 minus x1 squared plus y2 minus y1 squared, and that's all under the radical. Okay, so if we're looking at AB, we're going to take the distance from A back to B. So the x values for this distance, the x values are going to be cosine. We can say cosine of V minus cosine of U. Square that, and we'll add the y values, which is sine of V minus sine of U, and that's going to be equal to CD. Now the distance between for CD, well, we're just the difference in the x values is our cosine minus 1, and our y's is just sine minus 0. Okay, we'll square that. So let's go ahead and let's square both sides. So that means that not only is the radical going to go away, but we're going to square this first one. So we're going to get cosine squared of V, cosine squared of V minus 2 cosine V cosine U plus cosine squared of U. And then we're going to add sine squared of V minus 2 sine V sine U plus sine squared U, and that's going to be equal to, now we have to square the first one, cosine squared theta minus 2 cosine theta plus 1, and then we're going to go ahead and square sine of theta, which is so plus sine squared theta. If you need to take a real quick peek, so this connects with these three, and then this one squared to get these three terms, and then this one squared to get these three terms, and lastly this one went here. Okay, so I just wanted to clear that up for everybody in case you were a little confused. So now we're going to take cosine squared of V plus sine squared of V, and then we'll take cosine squared U plus sine squared U. Why would we do that? Well, we know that when we do cosine squared plus sine squared, we're going to get 1. So that helps to group these together. And then I can go ahead and I can do minus 2 cosine v cosine u. And then I can do minus 2 sine of v sine of u. And that's going to equal, then we're going to take cosine squared theta plus sine squared theta. And that's going to leave us with minus 2 cosine of theta plus 1. Tried to get that all to fit on 1 and it didn't. So here we go. So this one turns into 1, so we have 1 plus 1 minus 2 times the cosine v times the cosine of u minus 2 times the sine of u times the sine of v, that other one is, that right there was the sine of v times the sine of u, and that's going to equal, that becomes 1 minus 2 cosine of theta plus 1. So my ones I'm going to add together. I'm going to get 1 plus 1 equals 2. I'm going to get 1 plus 1 equals 2. And when I subtract 2 from both sides, they're going to cancel. So that'll come in the next step. So now that those two are going to cancel, this is going to cancel with this, I can go ahead and I can divide everything by -1. Actually, I can divide everything by -2. That's going to give me that the cosine v times the cosine u minus sine v times the sine of u is going to equal a positive cosine of theta. And when we go back to up here, when we go back to what theta equals, now we're going to write our final one, the cosine of theta, which is u minus v, is going to equal, and I'm just going to change the order real quick, the cosine of u times the cosine of v minus the sine of u times the sine of v. That, we just proved that identity, and on the next video I will do the sum for cosine, and we'll also have this one printed out.